So like I mentioned, we are going to, well, hey, how about that? I didn't see that coming. Okay, let's try that again. So as I mentioned, today we are going to start by taking some notes on paper. Actually, what I want to do is just establish sort of a title page for you for your notes. So just grab that highlighter and just nice big, we're just going to algebra, the dose, honors, a little squiggle action, and then 25, 26. So let's get a little just a title page for our notes. That way you can put this in your binder and keep it nice and neat and organized. All right. Everybody good on your title page? Okay, so let's jot this down. So we are on lesson 5. And the type of Mustang that we are going to get a little under the hood with now is something called a sequence. So this is our intro to sequences. Our intro to sequences. Wow, that's a big, thick line. I don't think I want one like that. I don't know why that's so big. Let's make that smaller. That should work. Much better. Before we actually jump right in there, I want you to just above that little title, put a little asterisk and then note, colon, lessons 1 through 4, C formative. I like that. So lessons 1 through 4, C formative. So that's where we'll find some of the previous information that we need. So this is our intro to sequences. So this is a type of relation, right? That's what we're looking at. It's going to be alphabetical from the top down. And then just look for P5. Okay. Because there is. Okay. All right. So again, just to kind of connect the analogy, right? So what we've done is we've kind of introduced this idea of functions, right? That's our Mustangs, right? It's a special kind of relation. And so we are going to look at a couple of special kinds of relations, these functions that are called sequences. So the first one that we want to talk about is an arithmetic sequence. An arithmetic sequence. And let's just kind of take I'm going to take a highlighter. I'm going to highlight some key words that we want to focus in on. So an arithmetic sequence is a sequence where we add the same amount to each successive term in the sequence. Okay, so what makes a sequence arithmetic by nature is us adding the same amount to each successive term in the sequence. Now, I'm going to underline this, add the same amount, and draw an arrow point down here because this is some important vocabulary that you need to know. What we call this same amount that's being added is the common difference. You're going to need to know this language. Common difference. You can put that in quotes. Okay? And that common difference is usually notated, let's just draw a little arrow over here, is usually notated with the letter D. So when we're talking about sequences, we're going to notate the common difference with the letter D. Okay, so let's talk about some arithmetic sequences here. So for example, I might give you something like this. 2, 7, 12, 17, and so on. Okay, a sequence. It's a successive list of values. That's the relationship. Remember I said relations can be numbers put together for any reason. So in sequences, these numbers are put together in this successive list. So you can see that this successive list right here has a pattern associated with it. And that pattern is take a term and add 5. Take a term and add 5. Each successive term comes from taking the previous term and adding 5. So we would say in this particular problem, the D equals 5. Common difference equals 5. This is the Mustang that we're looking at today. This idea of a successive list of numbers that are generated by adding the same term to get the next number in the sequence. That's the relationship that exists. Okay? Now, we could have one that looks like this. 31, 28, 25, 22. Okay. What do you notice when you look at this list of numbers? Do you see any mathematical relationship from one term to the next? Okay, there's a decreasing going on, right? But keep in mind, right? And it's a little weird in the language to say it's called a common difference, and I'll show you why in a minute, but it's adding the same amount. Okay? So when we write our D term, we have to write that as what amount is being added. So when we indicate this change here, what we're really doing is we're adding -3. Did you see that? We're adding -3. We're adding -3. So that makes our common difference term, our D term, -3. You see how that works? It's not a subtraction. It's an addition of a negative. Does it result in the same thing? Absolutely, because it is the same thing. But we write it in terms of an addition problem because that is the definition of this arithmetic sequence. Okay, let's talk about another one. How about if I give you 14.8, 18.5, 22.2, 25.9. Maybe not as obvious as the first one, and your job is going to be able to determine, is this sequence arithmetic or not? And if it is arithmetic, what is the common difference? That's your job, okay? Now, before we answer that question, let me give you a little something that might be helpful, okay? I'm going to give you a little formula for finding the common difference, and it's written like this. D is equal to, now watch this, it gets a little tricky. A sub n, it's like an exponent to the bottom. So A sub n minus A sub n minus 1. Again, it's like a little exponent only to the bottom. Now, you've actually seen this kind of notation before. I want you to think back to like distance formula. x2 minus x1, y2 minus y1, right? The little 1s and 2s were down below. But they weren't mathematical. They were descriptive. x2 and y2 are the x and y coordinates from ordered pair number 2. x1 and y1 are the ordered pair from ordered pair number 1, the x and y coordinates from ordered pair number 1. So what we have here is some descriptive information. Now, it's important that you need to know this right here. In fact, I'm going to box this in so that we have this handy for each other. And then we're going to say this right here. In this expression, or this equation that I wrote for you right here, we're going to say where n is the term number. Is the term number. So now what we're focused on is the term itself and what position is it in the sequence. Like, for example, 14.8 is the first term in the sequence. 22.2 is the third term in the sequence. Are you with me? Okay, so we need to know the term number and the value of the term itself. So there's two things now that we're looking at. Even though we don't write the term number now, we can figure them out, right? So if we wanted to calculate this, let's say a sub n, let's say n is the second term number. Okay, what's the second term number? What's the value of the second term? 18.5. So if I were to do a little math problem here, and I said, what's the common difference of the problem above? I would say, okay, well, the second term is 18.5. And I want to subtract from that a to the n minus 1. Well, if n was 2, what's 2 minus 1? 1. So what I want to do is take the second term and subtract from it the first term. Did you see what I just did there? Okay, watch. This is the second term in the sequence, right? Okay, so if I'm saying n is equal to 2, well then n minus 1 is equal to 1. So it's the second term, take away the first term. But it could be the third term, take away what? The second term. It could be the fifth term, take away what? The fourth term. You see what I'm doing? I get to pick any term number I want, and as long as I subtract the one that comes right before it, the 19th term, n equals 19, then this is going to be subtracting what term? The 18th term. Okay, now you're starting to see what I'm doing here. Okay, so 18.5 minus 14.8, what does that equal? Positive 3.7. So what we're saying is in reverse, there's a plus 3.7 here. Now, if this is an arithmetic sequence, we want to check and make sure that's the same common difference there. So what's 18.5 plus 3.7? Use your calculator. You're going to need your calculators for this class. You're going to want to take your calculators out every day. So 18.5 plus 3.7? Yeah, it is 22.2, isn't it? Okay, so this is plus. Let's check it one more time. What's 22.2 plus 3.7? It's 25.9, right? Okay, so now you can see that with this one, we have a common difference of 3.7. So what this little formula does for you right here is it allows you to find the common difference. If you know one term, you just subtract the previous term from it. That's how you determine the common difference. Okay? Now again, could we have used the same thing here? What's 7 take away 2? What's 12 take away 7? What's 17 take away 12? It's the same thing, but it's really easy to see right there, right? But what if I gave you this one right here? Arithmetic sequence or not? If it is, find the common difference. Go ahead, give it a shot. Let's see what you come up with. It is arithmetic, right? Common difference is 3/8. Well, you need to verify it, yes. But like what you'll have to do is for your work, you'll have to come up with the common difference. So you'll have to type it in. Okay? Yes, you can use your calculators for this. Yeah.
So like we would have to write all that math out?
No, you don't have to write all that math out. No. But I'm just showing you how it works. Okay? All right, so arithmetic sequences have a common adding number, positive or negative. Positive will make it go bigger, negative will make it go smaller. One particular aspect of this type of Mustang. Questions? Arithmetic sequence. Tell your neighbor what it's called again. It's a little weird sounding. All right, let's talk about then a geometric sequence.
How many hoods are on the Mustang?
We are looking at two sequences today, geometric sequence and arithmetic sequence. All right. I'm not going to get into the details today of why it's called geometric. We'll talk about that another time. But a geometric sequence is where we multiply the same amount to each successive term in the sequence. Okay, so a geometric sequence is where we multiply the same amount to each successive term in the sequence. Let's underline multiply the same amount and draw an arrow down here. This also has a special name, and this is called the common ratio. Common ratio, and that is often indicated with an R. So when we have a geometric sequence, we will have a common ratio, and we will indicate that with an R. Okay, so let's give you something to work with. 5, 15, 45, 135. Do you notice any kind of mathematical pattern? Okay, how about an adding pattern? Is there an adding pattern here? Well, to get from 5 to 15, you would have to add 10, right? To get from 15 to 45, you would have to add what? 30. To get from 45 to 135, you would have to add 90, right? Okay, so there's not an adding pattern going on here, so it's not arithmetic, but there is a timesing pattern going on here, right? And so what we're doing is we're multiplying by 3. And if we see that consistent ratio being multiplied there, then we can say this is a geometric sequence and our R is equal to 3. Now you're going to have to keep that clear. D goes with arithmetic for the common difference. R goes with geometric for the common ratio. Okay? All right, let's talk about this one. 567, 189, 63, 21, and so on. Any patterns? It's not divide by 7. Well, and actually it wouldn't be divide, would it? Because it's a multiply problem. Pierce, what do you think? Yeah, we're multiplying by a third. Exactly. Very good. We're multiplying by a third, right? Okay. Times 1/3. Which ends up really being division, right? So you can look for the division just like you could have looked for the subtraction from above, right? But you have to write it as a multiplication problem because when you write your common ratio number, your R number, you have to be able to multiply it. If I say divided by 1/3, I'm wrong. Because if I divide by 1/3, I'm really multiplying by 3. Okay? So keep that in mind. It's important that you understand that. Now, I'm going to give you this one. So 2.6, 0.78, 0.234, 0.0702, and so on. All right, now this one might be a little weird to find, so let's talk about, could we come up with a shortcut like we did up here for finding the common difference? And the answer is yes, we can. The common ratio is you take some term and you divide it by the previous term. That will give us the common ratio. You take some term and you divide it by the previous term. Think about, like, let's just go simple here, right? What is this one right here? So if we take 15 and we divide it by 5, we get 3. If we take 45 and we divide it by 15, we get 3. If we take 21 and we divide it by 63, 21 over 63, we're going to get 1/3. So stick with this pattern right here, and it will help you keep straight whether or not you have a fractional value. So use your calculator to determine, is this a sequence, geometric sequence? It is? Okay. If this is a geometric sequence, right, then it's going to need an R value. What is the R value for this one? Yeah, so this is 0.3 or 3/10, right? So you can show that by doing times 0.3 times 0.3 times 0.3. Okay, so we have two different types of sequences that we've looked at. We've looked at the arithmetic sequence, and we've looked at the geometric sequence. Okay, now I'm just gonna, I don't want anybody to pull out their iPads. Okay, I just want you to take a look up on the screen. I'm gonna show you what the formative for your homework is gonna look like so that you know how to then work on that and complete it. So everybody can take a look up here. We have just a few minutes left. So when you get to your homework, take a look up here. All right. You can see here that it says for each of the sequences, state whether there is a type to it, arithmetic, geometric, or neither. Give a reason why you know. Is there a common difference? Is there a common ratio, or is there none? And then using the correct variable notation, say the rule that determines the type. Is it D equals something? Is it R equals something? That's what you're going to type in each of these three boxes for the given sequences. The sequences are found right here. So for example, this sequence right here. Take a look at it. 8, 16, 24, 32. What do you see? No, it's not multiplied by 2 because 16 to 24 wouldn't be times by 2. Adding 8. What kind of a sequence is it? Arithmetic. How do we know that? Because it has a what do we call it? Common difference. And how would you write that common difference in that last box? D equals 8. Okay, so you will have a series of those to do. Hang on. Okay. All right, and then with each of these questions, read them carefully because they will ask you to do different things. Like this one says, the first two terms in the sequence are 2 and 6. Give the next term in the sequence for each type. Provide a brief explanation for how you know. So each type. So 2, 6, what if it's arithmetic? 2, 6, what if it's geometric? Okay? All right, let me see if there's any. This one's pretty much the same, just a little bit different. All right, now this one last thing to show you. So these, you're going to have some sequences given to you in diagrams. And your job is going to have to be to understand the diagram and the question and come up, is it arithmetic, geometric, or neither? And what is the common ratio or difference, and how do you know this? Okay? So read the questions carefully and give it your best shot. Let's see how you do. So then we'll pick back up again when I see you guys tomorrow. So this is due tomorrow. So don't dilly-dally.